All right. Well, I haven't posted anything in quite a while. I've been busy with schooling, learning how to become a coder. Um, and this video is about the class assignment that I had to recreate Conway's Game of Life. Now, for those of you who don't know what the Game of Life is, it's basically a simulation of automatons that represents life processes. So let me give you an idea of what that means. Let me go over here. So this is the finished version of it. It's on my website, and there will be a link in the description. And basically, you start off with one pattern of anything of your choice. We got the beacon pattern. Let me click the start button. And as you can see, all it does is just flash back and forth. Then we've got the blinker. And it just goes up and down, up and down. And a pattern that of my own creation. It's called the Lambda pattern because it's named after the school. It sort of represents the Greek lambda character, but not really. But you know, I'm not very good at making two-dimensional drawings, especially on a grid. But anyways, this is my representation of that. And in a few generations, the cellular automatons will all die out, except for the ones that don't do anything. Over here, we got three basic rules. Any cell with 2 or 3 neighbors will survive. Any dead cell with 2 or 3 live cells is resurrected. And all other live cells in the next generation and anything remaining and any remaining dead cells remain dead. And with a random feature, all the little black spots represent cells. We click start, and everything just starts generating. Every second, a new generation is born, and an old generation dies. Now, Conway's Game of Life was devised by a British mathematician, John Horton Conway, and is a demonstration of cellular automaton. I got the idea for the board from this tutorial, which a guy named Brian Caffey created a blog about making simple board games in React.js. And this comes directly from the Facebook React tutorial. And the board in question comes from down here, right here. And the code is the basic gist of the board came from this. Now let's look at the code. And as you can see, I adapted a few things to my own style for the actual squares of the board. Then the board is generated here, plus has all of the logic. I'm using React JavaScript classes. It's really just synthetic sugar. It's not really a class, but that's just what they call it. So the state management, I have 3 different states. One is running, and that's lets the computer, the simulation know that if it's running or not. And is 0, which counts for all of the objects in a two-dimensional array, which is really in JavaScript is just an array of arrays. I made the board 50 by 50, and that's what represents the grid. And of course, you got to bind all of the helper methods to that. This maps through it, and this will actually detect the changes in the state and will and the colors. Now the patterns, I had to create a new array of arrays. Switch case statements will determine how the patterns are done. So with the random, it generates a random number between 0 and 1 and populates the board. Pattern 2 would be the Lambda pattern. And that's the basic gist of the patterns. The real hard part was actually getting the patterns to animate. It took me a better part of a week, all week, to get this done. I set an interval, and this is what got the whole thing working. I was originally trying loops and all kinds of things, and nothing was working. I finally got some help and figured out, just setting an interval to 1 second will give the visual effect of it working. And then this here clears the handle stop, clears the interval, and the animation stops. And here's where all the magic is happening. If the is running is true, then all of this will execute until the stop button is pressed. And it's basically, I created a new array, empty new array of arrays. Another double a loop inside of a loop, and sets the first, this right here is the first rule. This is the second rule, and that's the third rule. And that basically is the code. And I will leave the link to the actual code in the description. This is live on my website if you want to see it work. But for those of you who like to look at the code and see how it works, maybe you have ideas for improvements. But that's the gist of the code. And we'll just leave you with the random pattern going again. Well, that's it for now. Thank you.